All right, we're going to do 1-5 angle relationships. Adjacent angles are two angles that lie in the same plane and have a common vertex and a common side, but no common interior points. Can't say that out loud. Oops. All right, I'm going to highlight this common side. So 1 second, guys, you'll be able to see it in just a second. Forgot to turn on my projector. No wonder you didn't know I was getting ready to go. Beautiful. You need to draw this, please, on your paper. So adjacent angles are two angles that lie in the same plane and have a common vertex and a common side, but no common interior points. This is the common vertex right here. The common side I highlighted. So you've got two angles here. You've got an angle right here and an angle right here. Those are the interior points of those angles, and they don't share any of those interior points. They're separated. So I'm going to say what you would maybe say in your own words. Most kids would describe these as angles next to each other. So if this is angle 1 and this is angle 2, angle 1 and angle 2 are adjacent. Okay, so we're going to talk about several kinds of angles. The next type is a pair of adjacent angles with non-common sides that are opposite rays. Okay, so these are the non-common sides here down at the bottom. They're opposite rays. That just means they form a straight line, so they're called a linear pair. Okay, and in your words, you'd probably say angles that make a line. All right, so over here, if I call this one angle 1 and this one angle 2, angle 1 is opening from here to here. Angle 2 is opening from here to here. They have no common interior points, and they are adjacent. And that would also show me that, bless you, the measure of angle 1 plus the measure of angle 2 is 180 degrees. Okay, anybody still need this page? Yes, okay. So there were two concepts on this one. The fact that they are adjacent, meaning they share a side, and that their non-common sides form a linear pair because they add up to a line. Okay. Next kind, vertical angles. Are two non-adjacent angles formed by two intersecting lines. So draw a pair of lines that cross, similar to mine. Okay, the interior of this angle is the same, this angle is the same size as this one. And likewise, this angle is the same size as this one. So if I call the ones I highlighted in green, 1 and 2, angle 1 and angle 2 are vertical angles. Now some kids think they have to go this way because of the word vertical, meaning going straight up and down. But these are also vertical, 3 and 4. Angle 3 and angle 4 are also vertical angles. All they have to do is somehow make these. Now here's a different way to say it. Most kids describe these as angles that are, what would you say? Say that again? Oh, good. Angles opposite each other. I've also heard kids say angles across from each other. Was anybody thinking across? I could spell it. Here we go. All right, angles opposite each other is very good. Now, one thing we would like to know is that angle, the measure of angle 1 equals the measure of angle 2. Vertical angles are congruent. And the measure of angle 3 equals the measure of angle 4. Okay, they are also equal to one another. There's another cute way to make yourself a big X like this. See the V in the word vertical there? Vertical angles. It's kind of a cute way to write it. Anyway, A for angles. Oh, I guess I forgot. I shouldn't have written the letter A, right? Because that is the A. Vertical angles. And they are congruent. All right, so let's make some little arcs on these. I'll do a double arc on 3 and 4 because I don't want you thinking that the angles are equal to each other. My pink ones are different than my green ones. And this I'm double, oh, I already did a double arc. Excuse me. Let me take one of those off. Single arc on 1 and 2. Okay. All right, next one is called, they are complementary angles. Complementary angles are two angles whose sum is 90. These angles could be adjacent or they could be non-adjacent, meaning not right next to each other. Your words, usually kids will say, two angles that add to 90. My pen stopped. If they have to add to 90, then they make these two right here form what kind of angle? Oh, they're both acute, but what kind is it when they are put together? Yeah, right angle. So there would be the box there, and this would be angle 1 and angle 2. The measure of angle 1 plus the measure of angle 2 is 90. Those are the kind of equations you'll be setting up. We'll be using these concepts in some equation solving. Okay, angle 1 is in here, angle 2 is in there, and put together they make 90 degrees. Down here, if I call this one angle A, they don't have to be adjacent, making this right angle. They could be a 40-degree angle A over here and angle B 50 degrees over here. Because you can add 40 and 50 and get 90, that means these are complementary angles. Angle B, A and B are complementary. So those are just examples. Now we're about to talk about another type of angles whose sum is not 90 but 180. And they're called supplementary. So I like to tell kids that to get them straight, complementary angles, they're the ones that add up to 90. Supplementary, S comes after C in the alphabet, and those two add up to 180. And 90 and 180, 90 is smaller than 180, C is before S in the alphabet. C goes with the 90 degrees, S, the supplementary, goes with the 180. So here we go with the next kind. Does anybody need this page still? Okay. I'll wait a minute. Bless you. Now I know some people need to listen and watch before they can write everything down. So that's why I keep asking if people are waiting. Some of you are able to do it all at once. Whatever works for you. Are we good? Almost? Okay. Okay. Yes? Thanks. All right, so the next kind, supplementary angles. Supplementary angles are two angles whose sum is 180. They have to be two. These angles can be adjacent or non-adjacent also. Adjacent supplementary angles are called a linear pair. Again, I'm going to call these angles 1 and 2. Angle 1 opens from here up. Angle 2, if you continue it, kept going until you get to a straight line. But they're different sizes, so you can measure it from either way. These are just not supposed to be the same. That's why I did a double arc. But the measure of angle 1 plus the measure of angle 2 equals 180. It was really messy. Okay, so in your own words, you probably would say two angles that add to 180. Where'd pen go? Uh-oh, it's disappeared. Two angles that add to 180. They don't have to be adjacent. They could be non-adjacent. So if this was angle D and this was angle C, somehow there we go. Oh, whatever. If this one was 40 degrees and this was 140, they would be supplementary because the sum of those numbers is 180. I was going to add a little example of some other supplementaries. If they were congruent supplementary, they would both be 90. So if you had two angles that were 90 degrees, they would be called supplementary too. And that's the only way that two angles can be supplementary and congruent, is if they're both 90. Okay, so this is not something for us. This is your first problems. On your paper, let's try using the concepts that we just discussed to name some types of angles. All right, I'm going to do a little bit of different colors if you like to do that. I would like to have you maybe help me if we see if we understood the concepts we just went over. And if I don't get any volunteers, I'll answer this first set of questions. But the second set, I'm going to ask you guys to help me out. I need to name a pair of vertical angles. There's more than one correct answer in here. But I think if I'm going to do that, I'm going to go over here, maybe. So if nobody wants to volunteer up 2 vertical angles for me. All right, I'll wait till the next go around then. All right, so right here, this angle, EFI, we have to name it with 3 letters, would be vertical with this angle, GFH. I'm going to get a pen. I have to name them with 3 letters. Angle EFI is vertical with angle EFH. Now, that's not the only answer. We could have done EFG and HFI. Next, it's asking me to name 2 adjacent angles. Did you want to ask me a question? Go ahead. Oh, you can go ahead and tell me another pair. Over here. The only bad part about over here to name them is ABC is vertical with EB, and then there's no letter on here. So that would be a pair, but I couldn't even name it. That's why I chose to go over here, because you couldn't name these. Like you could do this angle right here and this angle, but I don't have any point on there. So there are more over here, but you can do these 2. Okay. Let's go with some adjacent angles. If someone wants to help me with that, I don't mind. That'd be great. Next to each other. Angles that share a common ray. Okay. It's Kenny? EBD, okay. Angle, he said here, angle EBD should be right there. And say it again. DBC, great, yep. Good job. So then why are they are adjacent and they have this ray BD is the common side. Now, he just so happened to name the pair that we're going to need to use for number 4. Do you see why? 2 complementary angles. These also add up to 90. So that would be the answer also for number 4. Angle EBD and angle DBC. So there are a whole bunch of adjacent angles in this picture too. But I'm also now going to name a pair of supplementary angles. So I got number 4 done as well, because those would add up to 90. Supplementary means we're going to make a straight line when we put them together. So I'm going to do it over here. If I want to make a straight line, I could use this angle, and then I just have to go all the way to here. So that's one example, angle IFE. I hate that thing. All right, let me get rid of it. Get something that writes better. My highlighters don't like to do that. All right, angle IFE and angle EFG. Now, is there another angle that's supplementary to EFI? Do you see how I just made a straight line? Is there another way to go and make a straight line there? From here to, those are supplementary. So I could have done angle EFI and angle HFI or IFH. That pair, any direction, you could have done this one and this one, as long as you put them together and you get one straight line. All right, that was just another example. So we got a new picture here. I'm hoping I can get some more help on the next questions. So I'm going to look. It says name an angle or angle pair that satisfies each condition.
If I'm looking for adjacent, that's nice and easy if you understand that that means they're next to each other. Can somebody name me with 3 letters? I need 2 angles, 2 sets of 3 letters to name some more adjacent angles. Now, I know you understand adjacent, Kenny. I appreciate your enthusiasm. I was hoping for somebody else to try it. Evan? Sure. He said RTL, that angle, and angle LTN, this one. And yep, he's right, because that's just an example of a good pair of adjacent angles. Okay, now I need acute vertical angles. This is a little trickier. They need to be less than 90 and vertical. So I'm going to highlight something to help us visualize that. I'm going to highlight ray or line RE and SL. Because remember, they have to be made by lines that cross. So we're going to have to really work. We can't use these little baby ones here. I'm going to use that one and that. Now, it's not the only answer. Somebody could have gone with that big one here and this one. So if I use the pink ones, Olivia, how can I name this angle right here? I got to check on some understanding. Perfect. Yep. RTS. That would be great. And what's the angle that's vertical with angle RTS? Akasha. What angle is vertical with angle RTS? LT. Perfect. Yep. Angle LTE. Yep. Now, does somebody want to give us an alternative pair of vertical angles in the picture? Okay. Thank you, Emily. STE. Yep. And what's vertical with STE? What kind of angles would those be, though? Those would be bigger than 90, so those would have been an example of obtuse vertical angles. All right, so the ones we wrote down here were the ones that are acute, smaller than 90. So if I went here and here, those would have been obtuse verticals. They wouldn't have fit number 6. But I'm glad we're understanding what vertical angles are, I hope. That's so big in this whole year, knowing vertical angles. 2 supplementary adjacent angles. Supplementary meaning add up to 180 and are next to each other. Somebody want to help me with the pair of those that hasn't answered a question yet? Cadence? S. There's more than one answer too. So S. Which one? If I go SRL, now I'm gonna clear up a concept right now that'll hopefully make you totally get what I'm saying. If you told me SRL, I think you mean that. See how I drew it? Say it again. S. Did you want to do, okay, tell me, do I have one of the angles colored that you're trying to name so I can help you? Okay, they got to have a vertex of T. Okay, so just put T in the middle and then tell me which ones you're talking about. Not sure? Okay, thank you. And I'm going to find out why, because I want to help you make sure you can name them the way you mean to. Alyssa? RTE. Okay, RTE, this is great. I like that we're saying because I'm finding out some misconceptions. Okay, RTE is a straight angle. It's 180 degrees. So she's right about the total being 180 on that. But I want to name 2 angles that make a straight line. I got to put them together. I need 2 separate angles pushed together to make a straight line. Murphy?
Okay, angle RTS and angle STE. Yes, that is a pair that makes a straight line. You're on the right track, Alyssa, when you said about you're looking to try to make RTE. I bet somebody's got another answer for me now. There's actually 4 answers to this question in this picture. More than 4, actually. I think. Wait. Okay. Okay. Kayla? Yep. STR and RTL. Sure. Because STR is here, then RTL goes there. That works as well, these two. All right. So that's not wrong. If you had your own pair, that's another correct answer. There's another answer. Okay. Let me point this out. Maybe this will help. If I have 2 lines crossing, these guys are supplementary, agreed? They add up to a straight line. This one and this one add up to a straight line. You can go all the way around in a circle. This one and this one make a straight line. This one plus this one makes a straight line. You get what I'm going at? How many degrees are there all the way around a circle? 360, yep. And half of 360 is 180, okay? Half of 360 is 180. That's the 180 degrees in a straight line. Okay, an angle supplementary to RTS. All right, we're back to next 2. Supplementary, we want one that helps it make a straight line. Let's go with Kayla's answer of this one plus this one would be a straight angle. So supplementary to angle RTS would be angle RTL. It's not the only answer, though. It could have been STE. Okay, I've got to get to some of the problems that we're going to work out algebraically. Now, that was good learning. I felt like we got somewhere with some thought processes on the last one. So it took a little longer than I hoped, but we're going to be finishing the packet. That's the assignment. But I'm going to be doing many more examples. I know you're leaving now, so. Okay, identify 2 vertical angles. So let's see if we can get that concept down again. We need to name things with 3 letters here. You can pick up without your observance. Okay, so we got to find 2 lines that cross. What cross is that? That's going to help me find vertical angles. What other one should I highlight? S and T. Yep, all those points. Now, when you name a line, remember you only use 2 points to name it. Okay, now I want to name 2 vertical angles. As soon as you can find 2 lines crossing, you can find me vertical angles. Bryce, name me a pair of vertical angles, please. Okay. What's it vertical with? Perfect. Yep, that's good. TNU. Okay, how about a pair of acute angles that are right next to each other, which means it is what adjacent means. Priscilla? Want to try it? 2 acute, they got to be smaller than 90, and they got to be next to each other. You need a hint? BNT. Okay, so she's picking this one. Good. It's just that angle. Don't worry about this piece right there. And I need another one that's right next to it that's less than 90. So you actually have 2 different choices. RNV? Sure. And if you went down here, this one's also acute, so TNU would have been adjacent to it as well. Good. All right, I need an angle supplementary to angle TNU.
Okay, Darylyn, you wanted to give me, this is TNU right here. RNT, great, that'll work. Does anybody have another answer? Kenny? Or trying to grab somebody I haven't talked to. Lauren? How are you doing? Lauren? TNR. Yep, that works. That's the same as RNT. So you can just reverse the letters just fine. That is a good one. But I was going to get a different one. Oh, okay, Lauren. UNS. Yep. Yeah, good. All right, go. You could go that way. Is that what you were going to say? Good. Okay, I think I'm finding out that a lot of you are comprehending what I'm trying to get you to comprehend. All right, now this is hard for a lot of kids. So listen, please. This is, you see a 90 there. All right. And then you got to read these words and you say, what do I do? Find the measure of two complementary angles if the difference in their measures is 18. What does difference mean? Subtraction? Okay. So one's smaller than the other, right? All right. So let's let one of them be X. Big one or little one? Okay, good idea. Big one. And then I can write the little one is that same amount, my X, but I have to reduce it by 18. This is what you have to learn how to do to write the equation. Now, if they are complementary, then they add up to 90. So we're going to add these up the way we wrote them and set it equal to 90. X plus 2x is 2x. 2x minus 18 equals 90. Then I had to simplify first. Now I solve by adding 18 to both sides. I have 2 times x is equal to 108. I divide by 2, doing my algebra, 54. Okay, so that means that one of the angles is 54 degrees and the other, 54 minus 18 is 36. Oh, sorry. Did somebody still need that? All right, so now, could you do one if it said two angles are supplementary and it was the same thing? Then it would just be that they added up to 180 instead. Okay. And they would be different size. Can I go? Good. All right, perpendicular. Lines raised in segments that form 4 right angles are perpendicular. The symbol for perpendicular is an upside down capital T. The right angle symbol also indicates that the lines are perpendicular down here in this diagram. That means this is 90 also, this one's 90, and this one's 90. So once you have one right angle when lines intersect, you have 4. Aw, you have a cold? Yeah. There we go. So here we go with the picture, and this is a kind of questions you'll have on a future quiz. Find X so that ray DZ. I don't like the way they wrote that. Ray ZD is the way I see it, and ray ZP are perpendicular. If they're perpendicular, then angle DZP is 90, so these two angles added up will equal 90. 9x plus 5 plus 3x plus 1 is equal to 90. Combine your like terms, 9x and 3x. You get 12x, add your integers 5 and 1, that's plus 6 equals 90. You will subtract 6 from both sides and then divide by 12. What? It's okay. 12x equals 84.
divide by 12, and 84 divided by 12 will give us the value of x. And that's 7. And it did say just find x. I went back to check if they asked me for anything else, and they did not. Are we good? May I go on? All right, this one says find the value of x. So line NR is perpendicular to line MQ. That means we got right angles in all these corners. So if I want to find x, I'm going to use 5x and the x. They add up to 90. 5x plus 6x is 6x. Divide by 6. X is 15, right? That was a pretty simple one, wasn't it? That's the kind of thing you're looking for. You just have to understand. This is probably the new thing right here is to read this correctly. It says line NR is perpendicular to line MQ. And then you have to know what the word perpendicular means. It means that it forms right angles. Okay, 15. Find the value of y. This is also 90 degrees here. So 9y plus 18 equals 90. And we just have a simple algebra equation to solve then. Subtract 18. You get 9y is equal to 72. Divide by 9. And we get 8. Okay. Now, the story might be different. Let's see. EBF, angle EBF, that's in here. 3x plus 10. And then it says DBE is x. And that BD is perpendicular to BF. That means right here is a right angle. So they add up to 90 again. By the way, if you want to just add those in your head, simplify it right away, go ahead and do that. X plus 3x is 4x. You got 4x plus 10 equals 90. Subtract 10. We get 4x equals 80. What's that? Divide by 4, x is 20. So we don't do real hard equations in this class. We do pretty basic ones. Okay. 17. Oh my gosh, another one where this is a right angle. But then it asks you to plug back in and find the value of some of the missing things. Okay, I'm going to, you know what to do, right? Put these together and set it equal to 90. Then plug back in. I want to get to one that I haven't done. This one. Then I'll go back to 17 if we have a moment. What do these add up to? There you go. 180s. Basketball hoop. They do tend to lean a little bit forward. At least the ones that people have in their yards, in their driveways. Okay, so these angles add up to 180. Sometimes we line things up straight up and down, but those are not, that one's not straight up and down. So we don't want to assume it's at a 90-degree angle. Add your like terms. And then I got to do 8 minus 3 is 5, so it's positive 5. Then I need to start doing the algebra. Subtract 5 from both sides. Divide by 7, and we should get 25. Next, it asks us to find the measure of angle BCA. So we're going to do 3 times 25 plus 8. 75 plus 8, so that one's going to be an 83-degree angle.
And then 4 times 25 minus 3 is 100 minus 3. That's going to be 97. Okay, what I'd like you to do is continue with the rest of the packet. And then tomorrow I'll answer questions on it and we'll do some more practice on these concepts. So have a nice evening.